Welcome back, everybody. I'm Travis with Linux Academy. In our previous lesson, we went and discussed the theory behind Docker networking, which included the container network model, as well as the various components that the CNM implements. Now it's time for us to go and begin getting familiar with the networking commands. Now, before we jump into the commands, I want to go and execute a ifconfig. And this is going to show all of our adapters. Now, the first one we have here is Docker 0. This gets created when we go and install Docker, and this is a bridge network that is going to bind itself to ETH0 and our loopback device. Now, we do have a IP range assigned. It's a /16, and it's 172.17.0.0. This is the pool of IPs that Docker will be pulling from when you go and create a container. So when we execute a Docker container inspect and we find the IP, it's going to be coming from this pool. We're going to start off by executing docker network-h, and this is going to go and list all of the networking commands. Now, between this lesson and the next, we will cover all of these commands. So we're going to go and start off by executing docker network ls, which is going to go and list all of the networks that have been created on this host. Now, so far, I haven't created any new networks. These are the ones that are installed by default. As you can see, we have a bridge network. It's called bridge, as well as a host network that is also called host. And then we have none. Now, one very important thing that needs to be said is that if you go and delete any of the default networks, it's going to tank your Docker server. And at that point, you're going to be better off just going and reinstalling Docker. If you want to go and get the detailed information on a network, you're going to want to run a docker network inspect and then the name or ID of the network you want to look at. So we're going to go and execute a docker network inspect on bridge. Now, jumping to the top here, we're able to see all the details about our bridge, starting off with the name, which is called bridge, followed by the ID, the scope of the network, which is local, the driver that is being used, which is bridge, whether IPv6 is enabled, it is not. Under config is where we find the subnet and gateway information for our network. When we ran ifconfig, we saw that the following IP 172.17.0.1 was bound to the bridge, and that IP is coming from this subnet. And this CIDR block is set up by default when Docker is installed. Also under config, we can find the default gateway, which is 172.17.0.1. Jumping down the bottom, we can find some additional details about our network defined under options. The first one is default bridge. It is set up to true. The other important thing is the host binding for IPv4. Because we're using 0.0.0.0, it means the bridge is bound to all interfaces on the Docker server. And this is also where the bridge name is being defined. Previously, when we ran our ifconfig and we saw docker 0, this is where that is coming from. Now that we know how to go and list networks as well as inspect them, let's go and create one. To do this, we'll be using docker network create. There are a bunch of flags that are accompanied with this command, and that's something we'll be exploring more thoroughly in the next lesson. But for right now, we're just going to create br00, which is going to use the default settings. Let's go and take a look at the bridge we just created. Nothing real special going on here. It's pretty standard stuff. We have the name of our network, which is br00, the ID. The default scope is local. If we don't go and define what driver we'll be using, the default will be bridge. IPv6 will be disabled by default, and then we have our config settings. The next available CIDR block will be assigned to our network, and this happens to be 172.26.0.0/16. Based off that CIDR block, the gateway is going to be set to 172.26.0.1. Internal is set to false, which means that this bridge will be publicly accessible, and we don't have any options specified. Now, there's two ways of going and deleting networks. We can execute docker network rm and then specify the name or ID of the network we want to delete, or we can execute a docker network prune. Prune will go and delete all unused networks. Prune is a little bit more of a risky command because we're not controlling what network is going to be deleted. It's deleting all unused networks. Now let's go and delete br00. And when I execute docker network ls, you can see that network br00 is no longer there. Before I discuss how we can go and connect and remove a container from a network, I'm going to quickly set up our scenario. I'm going to start off by going and creating a container. I'm just going to call it network test 03. I'm assigning the published ports to 8081, mapping over to 80 on the container, and I'm just going to be using the Nginx image. Next up, I'm going to create a new bridge network called BR01. Okay, so now that I have our defaults in place, I want to talk about how we can go and connect a pre-existing container to a network. And we can achieve this by executing docker network connect. This command is going to take two options, the name of the network followed by the name of the container. Now we can execute a docker container inspect to verify that network test03 is indeed attached to network br01. By going and looking at the network section, we can see that our container is attached to br01. Because we didn't specify otherwise, the container is also attached to the bridge network. Okay, so now that we've gone and connected a container to a network, let's go and remove it. And we'll be doing this by using the docker network disconnect command. And just like connect, it takes two options. The first one being the name of the network, followed by the name of the container. And if I go and re-inspect the container, under network, we're now just using the default bridge. Coming up in the next lesson, we're going to dive a little bit deeper into networking, where we go and create a network and specify the subnet and gateway IP. We'll also be setting up a scenario where we create two containers and then have them communicate over an internal network. Go ahead and mark this lesson complete.